Hello everyone. In this video lecture, I will discuss about the realization of T flip-flop using SR flip-flop. So this is the block diagram of a T flip-flop using an SR flip-flop. As we have to construct T flip-flop, so we will give the T input as the input of next state decoder or the combinational circuit, and the outputs of this combinational circuit will be fed as the inputs to the SR flip-flop, and the outputs of the SR flip-flop Q and Q bar, they will be fed back to the input side of next state decoder. So here we have to find out the values of S and R, or the expression of S and R in terms of T and Q. So step 1 is the operation of T flip-flop. So this is already known to all of you, so I am not explaining it again. Now step 2 is the present state next state table of T flip-flop. So it is the present state next state table. Qn is the present state output, Qn plus 1 is the next state output, and T is the input. When present state output is 0, we are giving T as 0, then the output will remain unchanged in its next state value. So in next state value it will be 0 also. Now coming to this second case, where present state output is 0, we are giving T as 1, then the output will be toggled. So the next state output value will be just complement of the present state output value. So next state output value will be 1 here. In the third case, present state output is 1, T is 0. So the next state output will be same as the present state output, that is 1. In fourth case, Qn is 1, T is 1. As T is 1, so the output will be toggled. So the next state output will be just the complement of its present state output. So in present state output was 1. So next state the output will be 0. Now coming to step 3. In step 3, first we have to find out the excitation table of SR flip-flop. This thing is already known to all of you, the excitation table of SR flip-flop. So I am not going to explain it again. Okay, just giving you an overview of this excitation table. This Qn is present state output, Qn plus 1 is next state output, S and R, they are the inputs to the SR flip-flop. So these are the values of present state and next state, and these, according to this present state and next state output values, we are here creating the combinations of S and R values. Okay, so now we will append this excitation inputs, or this S and R input values, to this present state next state table of T flip-flop. Now by appending this excitation input values to this present state next state table of T flip-flop, we are getting this table, where the first 3 columns, this part constitute the PSNS table of T flip-flop, and the fourth and fifth columns, they are the input values. Fourth column is the S input, fifth column is the R input. Now when Qn is 0, Qn plus 1 is 0, T is 0, then we have to find out the values of S and R from the excitation table. Now from the excitation table, when Qn and Qn plus 1 both are 0, then S is 0, R is D. So we will write 0 under S, D under R. Similarly, for the second case, Qn is 0, Qn plus 1 is 1, T is 1. So we will find out the values of S and R for Qn 0, Qn plus 1 equal to 1 from its excitation table. So coming to excitation table, here Qn is 0, Qn plus 1 is 1, S is 1, R is 0. So we will write here that values. S is 1, R is 0. Similar way, you can find out the third and fourth row also. Now coming to step 4. Step 4, we will design the K-map to find out the expression of S and R in terms of T and Qn. So this first K-map is to find out the expression of S, and second K-map is to find out the expression of R. So we can say this is the excitation map for S, this is the excitation map for R. Now coming to the excitation map for S. This is Qn, this is T. So when Qn is 0, T is 0, that time what will be the value of S? When Qn is 0, T is 0, the value of S is also 0. So we are writing here 0. Next, when Qn is 0, Qn plus 1 is 1, then the value of S is 1. So Qn is 0, T is 1, that time the value of S is 1. So Qn is 0, T is 1, so value of S is 1. Next, Qn 1, T is 0. When Qn is 1, T is 0, value of S is D. So we are writing here D. Next, Qn is 1, T is 1, value of S is 0. Here Qn 1, T 1, S is 0. So we can form a group using only this 1. So what will be the expression of S? S will be equal to, here T is 1, Qn is 0. So S is equal to T into Qn bar. Now coming to the excitation map for R. So this is Qn, this is T. When Qn is 0, T is 0, then what is the value of R? Qn 0, T 0, value of R is D. So here we are writing D. Next, Qn is 0, T is 1, value of R is 0. So here Qn is 0, T is 1, value of R is 0. Next, Qn is 1, T is 0, R is 0. So Qn 1, T is 0, R is 0. Then Qn 1, T 1, R is 1. So here Qn 1, T 1, R is 1. So what will be the expression for R? We have to find out this expression of R using only this group. There is a group consisting of this 1 only. So R is equal to, here T is 1 and Qn is also 1. So R is equal to T into Qn. Now if we look at these two expressions, we can find out that there is two AND gates. Here is one AND gate and here is another AND gate. So for the first AND gate, the inputs of the AND gate will be T and Qn bar. For the second AND gate, the inputs to the AND gate will be T and Qn. So now we can construct the combinational circuit or the next state decoder. Coming to step 5. In step 5, we are constructing the next decoder here. So there are two AND gates. This is one AND gate, this is another AND gate. Inputs of first AND gates are T and Q bar, and the inputs of the second AND gate are T and Q. So this part construct the next decoder, and the output of this SR flip-flop Q and Q bar, they will change according to the input value of T. That means we can say, we can here whatever input values we are giving at T, we will get the output values according to that input values of T. So this is a T flip-flop, and an SR flip-flop is used to construct this T flip-flop. So this is the realization of T flip-flop using an SR flip-flop. Thank you.